Today we are going to be finding derivatives of exponential functions. So, exponential functions, these are a type of transcendental function. Exponential functions, trig functions, log functions, and the inverses to those. Those are transcendental functions. A transcendental function is an analytic function that does not satisfy a polynomial equation. That is in contrast to algebraic functions. Okay? Let's review some exponent properties. These are not exponential functions, but we're going to use them to recall some exponent properties. If you have a product being raised to a power, you can take each of those individually and raise those to that power. Okay? If you have the product of x to the m times x to the n, you can write that as x to the m plus n. If you have the mth root of x to the n, that would be x to the n over m power. If you have x to the m being raised to the nth power, you multiply those powers together. X to the 0 is 1. X to the negative 1 is 1 over x. X to the negative 2 is 1 over x squared, etc. Okay, it is important, this is a common mistake I see kids make. X to the m plus y to the n is, that should be an x there. X to the m plus x to the n is not x to the m plus n. Not. Okay? Alright. So yeah, none of those are exponential functions, okay? An exponential function has the variable as the exponent, and these do not have a variable as the exponent, all right? But the properties, these exponent properties, apply the same way. All right. What does the graph of y equals e to the x look like? We did this in the fall. I am sure you guys remember this. Looks like that, where this is on the y-axis 1. The limit as x goes to negative infinity, as x goes to negative infinity, e to the x is going to 0. As x goes to positive infinity, the function is going to infinity. And there is a horizontal asymptote of the x-axis. Or you can call that y equals 0. E to the x is never negative. E raised to any power is never negative. It's always positive. And lastly, ln of x and e to the x are inverses of each other. That means they undo each other. ln of e to the x is x. E to the ln of x is x. They undo each other. All right. So now let's start talking about the calculus part of it. Let's start talking about the derivative of e to the x. We're going to explore this graphically. I'm not going to prove this to you, but I'm going to explore it graphically with you. Okay, we did this when we did the derivative of sine x. Trying to get rid of that glare. There we go. Okay, so let's get your calculator out and let's put in e to the x. Let's confirm. There's e to the x. I'm just going to do zoom 4. There's e to the x. Looks very similar to what I graphed up above. Okay, now down in for y2, I'd like to graph the derivative of e to the x. So math 8 with respect to x of e to the x. And I want to graph this for all values of x, so I'm going to put an x right there. So when I hit graph, it's going to graph the derivative. It's still going to display e to the x in blue, and then it'll graph the derivative in red. Well, that's interesting. It appears that they lie on top of each other. What does that mean? That means that the derivative of e to the x is e to the x. I can think of only one other function whose derivative is itself, and I'm going to let you try to think of that. Okay? So if we have, if we extend this derivative to what if you don't have just a plain x there? What if you're taking the derivative of e to the 2x or e to the 3x or e to the x squared? What do? You apply the chain rule. So it'll still be e to the 2x, but then you multiply by the derivative of your argument, your derivative of your exponent. So this would be the derivative of u, e to the u. We usually put the derivative out in front and leave the exponential part in the back. U prime, e to the u. Okay? So, that's great. That is fantastic, and it's very easy. Derivative of e to the x is e to the x. Derivative of e to the u is u prime, e to the u. What if our base is not an e? What if it's something like a 2 or a 3 or a 5 or a 7 or any other number there? So I'm going to walk you through the process of finding the derivative of this. I'm going to start with y is equal to 3 to the x. And we're going to begin by taking the log of both sides. I'm going to take ln of both sides. So then I have ln of y is equal to ln of 3 to the x. Now I'm going to apply the log property that says that I can take this power on the argument and I can move it to the front of the log, right? So we'll have ln of y is equal to x ln of 3. Ln of 3 is just a number, just like 7 or 9 or 10 or whatever. It's just a number. So since it's a number, I'm going to write it out in front where we usually see a coefficient. That's just the coefficient of x. Okay? Now I'm going to take the derivative of both sides. I'm going to take the derivative of both sides with respect to x. Derivative with respect to x. The derivative of ln of y is, okay, u prime over u, right? So y prime over y. Yeah? And that is equal to the derivative of ln of 3 times x. Well, what would be the derivative of 7x? That would be just 7. The derivative of 9x would just be 9. So the derivative of ln of 3x would just be ln of 3. Y prime is another way to write dy dx. I'm going to multiply both sides by the y. I'm going to write the y first, I think. And now I'm going to substitute back in what y is equal to. Dy dx is equal to 3 to the x times ln 3. So now we know what the derivative of of 3 to the x is. The derivative of 3 to the x is 3 to the x ln 3. So let's recap. Derivative of e to the x is e to the x. Derivative of e to the u is e to the u. The derivative of a to the x, where a is any constant, a for any constant, okay, is a to the x ln of a. Ln of the base, remember, ln of the base. So we can apply the chain rule there too. Oops, this was u prime e to the u over here, the derivative of e to the u. U prime e to the u. The derivative of a to the u prime a to the u ln a. Ln of the base. Okay? We could have even applied that to a base of e because ln of e is 1. Okay. It is crucial that you not use the power rule on exponential functions. The power rule only works for when you have a power that is a number. Okay? If you have a power that has an x in it, you do not use the power rule. Okay. Examples. Let's find the instantaneous rate of change. That's derivative. Find the instantaneous rate of change of e to the 4x cubed when x is a half. So first I'm going to find dy dx. in terms of x, and then I'm going to plug in 1/2 for x. Okay, there's my e to the u, where u is the 4x cubed. So u prime e to the u, 12x squared e to the 4x cubed. Now I'm going to plug in 1/2 for x. So we'll have 12 times x squared will be 1/4 e to the 4x cubed, that'll be 4 times 1/8, that is 1/2. So this is 3e to the 1/2. That's choice B. Okay, next example. Next set of examples here. The derivative of e to the x is e to the x. The derivative of e to the 2x is 2. E to the 2x. The derivative of e to the 5x, 5. E to the 5x. The derivative of e to the negative x, -1 e to the negative x. The derivative of e to the negative 2/3 x, negative 2/3 e to the negative 2/3 x. E to the negative x over 2, negative 1/2 e to the negative x over 2. Remember, dividing by 2 is the same as multiplying by 1/2. Okay. Easy, easy peasy. All right. If this is g, let's find the slope of the tangent line. That's derivative. Let's find the slope of the tangent line to g in terms of x. So I see a quotient, so I'm going to use the quotient rule. Start at the top and take the derivative. The derivative of the top is 2e to the 2x. Multiply by the bottom left alone. Minus is in the quotient rule. Now the derivative of the bottom is 2e to the 2x. Multiply by the top left alone. All divided by the bottom left alone, but squared. Okay. Let's clean this up. I'm looking at my choices. Let's clean this up. The denominator seems to be done because we got the same denominator as every denominator, so all we have to do is clean up the top. So you guys, I noticed that I have something in common. This is in common in both of these terms. So instead of distributing, which we could do, instead of distributing, I'm going to factor that out. I'm going to factor out an e to the 2x. I'm left with e to the 2x plus 1 from that term minus e to the 2x minus 1 from this term. I'm going to distribute this negative, so it's going to be a minus e to the 2x minus a negative 1, so plus 1 over that denominator. Okay, and now e to the 2x, negative e to the 2x. 1 plus 1 is 2. 2 times 2 is 4, so we get 4e to the 2x over e to the 2x plus 1 squared. And that looks like choice A. Quotient rule, and then clean up. Okay, let's find h prime of x here. Here we need to use the product rule. So start with the first term, take its derivative. Derivative of x is 1. Multiply by e to the x left alone. Plus, now we're leaving the x alone and multiplying by the derivative of e to the x, which is e to the x. So we get e to the x plus x e to the x. That's not one of my choices. What did they do? They factored out what is in common. The e to the x is in common. So we're left with e to the x times 1 plus x. That is choice C. Okay, find dy dx if y is 3 to the 4x squared. Well, here's my u. So u prime, I start with my u prime. So 8x 3 to the 4x squared times ln 3, ln of the base. And that looks like choice A. Let's find the slope of the tangent line to this curve in terms of x. It's an ln, so I look over here, and there is my u. So we're going to do u prime over u. Okay? U prime. So the derivative of e to the 3x is 3e to the 3x minus 2x, that's the u prime, over u. Leave it alone. That's it. And we cannot clean that up, so don't do anything to that. Okay, one last example. The graphs of f and g are shown. If h is this function, what is h prime of 6? So h prime of x is equal to, I have e to a power, right? So I'm going to do u prime e to the u. U prime e to the u. So I start up at my power and take the derivative. Well, I see a product up here, so my derivative is going to be a product rule. Okay, start with f, take the derivative, multiply by the g left alone, plus for product rule, now g prime times the f left alone. That's just the u prime, and now we need e to the u, so e to the f of x times g of x. Now we are plugging in 6 for x. So I'm going over here to where x is 6. This is f of 6, that's 1. This is g of 6, that is 6. Okay, so I start here at f prime of x. So f prime of 6, what is the slope of the tangent line right here? Well, the slope is right on the line, so that's a -1. G of 6 is 6 plus g prime of 6, the slope right here, the slope of the tangent line right here. Well, that is up 1 over 2, so 1/2. Times f of x, that's 1. F of 6 is 1. And then we have e to the f of 6 times g of 6. F of 6 times g of 6 is 6. And now we have -6 plus 1/2 e to the 6th. That is -12 over 2 plus 1 over 2. That is -11 over 2 e to the 6th. And that is choice D. Okay, and that is derivatives of exponential functions.